Good morning. Welcome to lecture 30 on thermodynamics of materials. Today we will continue and finish assignment number 3. The last problem we will take up. That is problem number 6. Okay. And one thing you note, your first class test syllabus is 3 assignments that we have covered, 1, 2, 3, and the lecture materials that up to adiabatic flame temperature. Okay. And it is due to take place which day? That is next Wednesday, means it is 31st. 31st of first class test. 31st of 31st May 31st. Note this, and time is 10 to 11. Okay, you come sharp, because you have lab access. So this is one thing. So Tuesday is what happens. Tuesday, just round go quickly. Tuesdays. Do you have? Are you free? Tuesdays class I get. Shall I get Tuesdays class? No problem, too. Class test Wednesday. Okay, it's okay. Can I continue? Yeah. Okay. Thank you very much. So very good. And yeah, I'm writing. The problem 6 reads as follows. Problem 6: carbon is being burnt with oxygen enriched air to give a gas containing 36.1% CO, 6.6% CO2, rest nitrogen. Reactants are at room temperature. Yes, sure.
Yes, sir.
Then it is not there. It is okay.
I turned on the light. It just got hot.
You may watch. Huh? So can you maintain? So maybe okay. Well, you sit down. You sit down. Okay, don't worry. Huh? Sit down. So I will just quickly, since perhaps there was actually a recording problem, so I am just repeating this one. So overall reaction is this. This is the adiabatic condition and constant pressure condition, and we normally consider for this. And this is actually okay. So open to okay constant pressure, and this is the product. Overall reaction product is a T flame. Flame temperature is the. And why do we consider breakup? So answer is this. Answer is this. Is what? I tell you what. The answer will be your. First of all, sir, this is 298. This is not same temperature. So heat of reaction will not work. Same temperature, heat of reaction. One problem. But no, okay, sir. But different temperature we also use, like heating state. But that is same thing heating. Same species heating from one temperature to another temperature. So it is neither fitting this or that. It is a conglomerate. It is actually a mess up. So total mess. So that's why we will straighten the mess. What is this, sir? That means it is neither this reaction. This is involving a reaction, sir, but not at the same temperature. So we will consider two-step procedure, two-step or multiple step also. But theme is two. The theme is actually that it is broken into a reaction step and followed by heating step. Heating step means temperature will increase. Okay, so I am doing that. So first of all, write what? You write this step breakup A. Where is carbon solid plus 0.577 O2 plus 1.34 nitrogen. Tell me what temperature it is? 298 K goes to the same temperature. Then it will be reaction. Okay, good. You are following now. Very good. If you follow, then no problem. What temperature you write here? 298 K. That's it. This is a pure reaction. See, reactant and product. That's it. Second step would be what? Obviously, you take this up to the final temperature. That's it. That's second step. So write that 0.845 CO plus 0.155 CO2 plus 1.34 nitrogen goes from 298 K to D2. D2 actually, the D2 is the same it should be 0.845 CO plus, tell me, plus, okay, CO plus 0.155 CO2 and plus 1.34 nitrogen. What is the temperature? T flame. T flame. I am removing this. T flame, just right. T flame. F means flame temperature. FL is flame temperature. So these two. So you know what is, you can write here? No, I will write this. Okay. Fine. So you may note this here. Okay. Delta H is what? How much? Do one by one. Delta H. Go delta H. Please tell me what is delta H. Good point. Delta H is what? Please tell me. You see, it is a reaction. So this is purely reaction. It is what type of reaction? Combustion. Or general name is heat of reaction. All reactions are heat of reaction. But then how you get the delta H of that? Yes, Somo. How you get the delta H of this? This reaction? Yes, the heat of reaction. Delta H is the heat of reaction. I'll get in terms of what we do in terms of data, or at least available data, or we know what is that? Formations only. Formation data are typically given. This is a formation. See, the formation, why? It's a CO is written means formation. So in terms of formation, shall I write in terms of formation, right hand side 0.845 delta H CO plus 0.155 delta H CO2, and what else I'll write? What else I'll write? These are written. These. What else I'll write? This one. What is the comment about this one or this one, etc. First of all, this 1.34 nitrogen is cancelling both sides. But what is this? Shall I include? No. So this is this answer. So you substitute the value. Point careful only in terms of the compounds, the formed species. So heat of formation. 0.8, what is the delta CH here? Right, minus 112 plus 0.155. What is the delta HCO2? Minus 394 gives you a mammoth value of what? Have you done this? Very good. So what is the answer? You tell me. Minus 156 kilojoule is okay. And for some reason, I tell you what, I'm writing it in the joule. Joule. For some why? This will be in joule actually. It is better. So many CPs are coming in the line. So joule. So I'm writing in joules. Otherwise, no interest. Okay. So minus 156 000 joule. Okay. It's okay. Happy to. Fast is over. Delta HB will be what? Now it is a time to. Can I remove this side? This problem. Okay, give a star here and star there. Continue. Delta HB. Please tell me. It is purely. Oh, tell me what is the delta H? Please tell me. I'll be very happy. Actually, let us see. Oh yeah, Anurag perhaps will be able. See this. This is actually the species exactly same. Only change in temperature, heating. No, I say heating. Yes. NCPT. Why NCPT? What is the reason? Yes, your answer? No. Delta H is NCPT. Constant pressure, so delta H is NCPT. Because delta H have written left hand side, what I have started? It must be NCPT. If you are delta U, it should be NCPT. If delta U would be NCPT, and we consider this behavior, okay, so ideal gases. Always delta H is NCPT, irrespective of this, okay? So delta H is hence fasting heat, NCPT. Okay, and delta H, okay, so good boy, so NCP, so how many, so CO, attack CO first, 0.845 answer. So I am writing for you, 0.845 Cp CO dt, temperature is moving from 298 to T flame. Second term would be what, you add here, keep on adding here, Cp CO dt I will add later on, what is this, plus, what, acha, dt, okay, dt, right, plus what is Cp of, oh no, it's better, no, keep it, right, keep it here. Plus second term is what, how many moles? 0.155, please write, 155, integration Cp CO2 dt quickly, 298 T flame, and last is, nitrogen is 1.34, good, 1.34 Cp nitrogen dt, 298 T flame. I tell you at this stage, okay, let me write at least 0.8545. What is CpCO? You copy from here, top. CO is where? What is CO? CpCO? Oh, right hand side. Good. 28.41. Quickly, plus 4.10 times 10 to the power minus 3 T. See here, minus 0.46 times 10 to the power 5 T to the power minus 2, and give a dt here, and integration sign here. Do this. Let's give a bracket, integration sign 298 to T flame, okay, and that give a bracket, third bracket here, maybe this thing, okay, CpDT. Plus next is here, concentrate here, plus second term is what? Carbon monoxide, carbon dioxide, again similarly 298 T flame. What is the CpCO2? Read it, okay, this 44.14, 44.14 quickly, plus 9.0 quickly, 9.04 times 10 to the power minus 3D minus 8.54 10 to the power 5 T to the power minus 2, and give a bracket, fencing, and make a dt there, and this integration is here, and everything, and this. So these three terms. Oh no, not yet. Over. Nitrogen is simpler because it is only one term Cp. What is that? Write that. What is that? 20.79 dt, and temperature running from 298 to T flame as before. Okay, so these three terms are there. Shall I don't need anything here. I need here, okay, shall I? These data are over, these data are over. So remove this, remove this, remove this, remove this. Assignment 3 continued, remove this. Again from this point, double star go up here. Come up here, okay? So delta HB is what? Continue. Delta HB is pretty lengthy. Is what? I'm doing something. You follow with me. I'm writing 0.845. Let time. 0.845 outside. Okay, integration you know very well. What I'm doing, I'm ignoring. I will give you. So I ignore. Even last day I showed you the second term, third term contributions are less. So this is already complicated, and to have an approximate value. To have an approximate, you don't claim that it is actually 100% correct. Okay, it is actually purest value. No, it is approximate. So I ignored these two terms. Okay. Moreover, I tell you here itself. For your examination, I will never give such complications. Okay. I will not test for your integration capabilities. Okay, how much you integrate these complications I will not make. I will give you this is very simple for integration purpose. Simple things. Okay. Simple. Like the first term. Okay. Maybe I don't. Then so that you don't have any difficulties. But thermodynamic part you have to consider. So can I do one by one? So if you ignoring, I will write that at the end. What is that? First CP. What is this? Oh, sorry. Yes, correct here. So tell me what it is. It is 28.41 first term. 28.41. Okay. Times what? T flame minus 298 first term. CP, CO first term. Okay. Integration dt is T. Integration dt, you know this. Next is what? Tell me. 0.155. 0.155. What is the first term? 44 point. Achha, right here approximately. This sign is important. Approximately is 44.14. T flame plus last term is 1.34. 20.79. T flame minus 298. Right here. Ignoring the right. What is that term? T terms containing T to the power minus T in CP relation. For the purpose of approximate result. For the purpose of approximate results. Getting approximate result. To be meticulous, rigorous, you do this full integration. You do yourself. You will check that approximate or getting approximate result. Don't worry, this part I am giving you. Okay. So giving this, what is this? Delta HB. So I remove all these things are all okay, unnecessary now, all over. Then this will be, I tell you, I give you these values. This will be roughly this one. 58 point, you can check this. Is 58.7 times 58.7. 58.7 times 58.7 TF minus 298. T flame temperature TFL T flame. So now take up. What is the delta H1 in overall? Are you ready there? Ready with you? Now we have 0 is delta H1, which is made up of two steps A and B. Delta HA plus delta HB. This gives us delta HB is nothing but minus delta HA. So, or delta HB is nothing but minus delta HA, which is nothing but minus is already delta HA is found where somewhere plus 156,000 joule. Okay, happy? 156,000 joule. And this is what unit? Guess. This I have not written. I forgot. What is the unit? What is the unit? See, these are the units where this CP dt, CP unit, which unit is given? Joule. Joule. So Joule integration. So Joule. It's okay. So it is also Joule. Joule of that reaction. See, per mole. Don't say. I tell you, who said per mole? Actually, yours perhaps about to say. The reaction was okay. You say. So follow. Hello. Yes, Amorto and you others also all follow. This delta H, for example, you take actually kind of conflict argument. Okay, is that sir fine sir delta H B is this. So what shall I write sir delta H B? Sir this is joule only joule or per mole. Now careful. So delta H should be joule, okay, but per mole sometimes you read in right sometimes. So what should we write? I said delta H for these reaction delta Hb. That means for what it is delta Hb is this one. For this for 845 moles of CO. So if you write to per 0.845 moles CO you have to write, and per mole of CO is what you have to convert. So this is the trick. You don't have to imply for this reaction. For this reaction, see how many moles there. They can ask back. Retort. So what is this? See how many moles? No, so these moles all for that matter 0.155 moles or for that matter. So any of joule have written. This is joule. All are joule. So they are set that HB is what as you written 58.7. Once more I am writing T flame minus 298 is 156,000 and then you get T flame. How much? Maybe you're right. 295 exactly. Oh yeah, you are very fast in calculating. You very good. 2955 Kelvin answer. This is the adiabatic flame temperature. Which is also known as what? AF. This concludes assignment number 3 and all problems all covered. So all everything. So since time is actually short, and moreover, I'll start next class. Let me write at least over. So first, can I remove this side? So I'm writing it. It will be helpful for you. And general comments. I'm not starting actually anything new. So I'm writing that. So with this, the first law of thermodynamics. First law of thermodynamics, including thermochemistry is over, is completed. That's it, all over. First law, call it there, and what a bit, and then first law, introduction already. Before first law, it was all introductory terminologies. This is the kind of 2-phase or 3-phase, okay, 2-phase or 3-phase study, okay, over. Now, this is general. The next class, not today, next class will begin the second law of thermodynamics. Second law of thermodynamics. Entropy. That's it. So happy you all happy. So with this actually we have completed today's class. Let us call it a day now. Okay. So thank you very much. Thank you very much.